Good day, ladies and gentlemen. This is Sarel van Greden, aka Mr. VG. And in this video, we are going to look at the variations on future value annuities. In the previous video, we looked at variations on the present value annuity. But variations on the future value annuity is very, very simple and straightforward if you understand how future value annuities work. So the first variation we are going to look at is starting at the beginning. What do I mean? Remember that any annuity, a normal annuity, you take out the annuity or the loan or the savings to start at the end of the first period, end of the first month, end of the first day, end of the first year. But what if we say, I don't want to wait 1 month. I want to try and capitalize on one extra payment. For example, Kaylin invests R2 per day for 3 years. Ignore leap years. We don't want to complicate things. At an interest rate of 8% per annum, compounded daily. Again, her payment is per day and compounded daily must correspond. She starts on her 12th birthday. How much will she have on her 15th birthday? So if we draw it as a timeline, at time 0, she now starts paying R2. 1 month or 1 day later, she pays another R2 and another R2 and another R2. Up until her 12th birthday, she will pay the last R2 into the bank account and get the rest back. So when we think about this, it's number 1, a periodic payment, and number 2, I want the value right at the end. Our interest rate is 8% per annum, compounded daily. Our N, now here's where the trick comes in. It's not just 3 years of payments. I start at time 0, that's my first payment, then at time 1, then at time 2, 3. And if you think about that, there'll be 1,095 payments plus the extra payment you are making, the one where you start at the beginning. And that's the difference. It's literally just one extra payment when I start at the beginning. So to substitute then into my formula is relatively straightforward. It is an annuity. I've got payout at the end. So my future value annuity looks like that. Putting it into my calculator gives me a total of R2,477.39. So that's how much she will get out on her 18th birthday. So if I start at the beginning, it means 1 extra payment. Our second variation is stopping a payment before the payout. For instance, Paul makes half-yearly payments into a bank account to the value of R20,000 at an interest rate of 13% per annum compounded semi-annually. He starts the payments after 6 months and stops the payments after 3 years, but will leave the money into the account for a further 18 months. Okay. Something that examiners love to do is they give you information that is in different periods than the payments. Because the payments are semi-annually or half-yearly. But now they're talking about months. So first of all, once you've drawn your timeline, just convert everything into half years. So the 6 months is 1 half year. So after 1 half year, I pay 20,000. That's perfect. That means it's a normal annuity, starting at the end of the first period, stopping after 3 years. So 3 years is 6 half years. So after 6 half years, he stops making the payments in there. Now a further 18 months is 3 half years. So I leave the money from 6.5 years up to 9.5 years, because there's 3.5 years or 18 months. How much will he have at the end? So when I look at this, I want to know how much it is valued there. But my future value is always calculated on the last day that payment is made. But then what's going to happen between the 6th half year and the 9th half year? Are you going to say to the bank, oh, just leave it there, don't worry, just give me that money at the end? Or are you going to tell them, give me interest, I want my interest? Well, you're going to want interest. So you are going to inflate that. You're going to want to make it as big as possible. So in other words, I'm going to take my future value, normal annuity, paid out at the end, and I am going to add 3 months or 3.5 years worth of interest. And that gives me a total value of 170,652 rand and 54 cents. So in other words, this 3 that you add is the missing payment months. So in other words, it's just inflating your future value for however long you leave it until you eventually withdraw it out of the bank. So to recap, we did 2 things in this video. Number 1, what if I start at the beginning? Then I just add 1 onto my number of payments. But what if I stop early and I just leave my money in the bank? Then for however long you leave it, that is how many months or years worth of interest you've got to add on top of the future value. So you are inflating your future value. And that, ladies and gentlemen, is it. As simple and as easy as that. Now, there are more variations, but they become so complicated that I'm not going to look at it, because it's not within the scope of your CAPS curriculum to actually look at all the possible variations, because a lot of it starts going towards AP Maths or further study maths. It's not part of your normal maths curriculum. So this is Mr. VG signing out. In our next video, we are going to look at bringing in logs to calculate your number of payments. So have a beautiful, wonderful rest of your day. Keep well. Cheers.